Hello, I'm Gundars Oswald, the program chair, and I'm here to introduce Dave Rico, who is, I've known for over 12 years. We worked in a couple different programs together. And the reason that he's impressed me over the years was he's always been a studier of information. You know, you can see where he's written a couple of books, maybe a half a dozen books, but he's written them by researching and evaluating what's out there and who's doing what. And so I think his presentation today will show him looking at all the different ways that program management is being done out there and what he recommends which way to go. So I think let's go and have Dave tell us all about it.
Thank you very much. Again, my name is Dave Rico. Thanks for coming out on such a cold night. I almost didn't want to come out myself, so kudos to you. You should give yourselves a big hand. This is actually my second talk here. I think I was first invited here in, I want to say 2009, 2010. I was 70 pounds heavier, so you might not recognize me if you were here back then. Let's go ahead and get started here. What we're going to talk a little bit about today is the notion of Agile project management. You know, specifically, you know, for projects and programs and things like that, bigger things, right? So most of us by now, Agile methods are a fairly dated phenomena, you know, at least 20, 25 years, right? So most of us are familiar with the basic Agile concepts like perhaps Scrum, and we're going to talk a little bit about Scrum today. But about a decade ago, a notion sort of started to emerge. It was an idea. It's sort of antithetical to a certain extent. The notion that we might actually do project management associated with Agile methods, you know, associated with Scrum. And that's what we're here to talk about today. Today we have even bigger frameworks starting to emerge, like the scaled Agile framework. But this is a good lead into that because there's a lot of the same basic mechanics. You know, think about that. I mean, we've seen some big safe contracts. We have the DHM-SM, which is the follow-on to IEHR, which is a $4.3 billion Agile project, right? Okay, so these concepts are very, very relevant in the public sector. We've had NGA's $34 million AWS project that was just awarded. We have the US courts just awarded $115 million Agile project. So if you're a systems or a software engineer in the public sector, concepts like Agile project management and Agile for really big public sector acquisitions is sort of a smoking hot topic. So there's a lot of good things we're going to talk about here today. So let's keep on moving forward. I won't talk a lot about myself. Most of you can read it on the flyer or have already read it. I've basically been in the public sector since the 1980s. As I was mentioning to Ellie Gianni and Gundars earlier today, I started on NASA's space station program, right? We were doing the onboard, you know, command and control system. That's sort of kind of where I started, you know. Moved on to things like fighter jets and missiles and radars, and eventually came here to Fort Meade and mostly networks and information systems and case file systems and things like that, all right? Really, if I were to point out one word or phrase in my background, is really, that's kind of been the focus of almost my entire public sector career right there, is really methodologies, right? Whether it was systems engineering or software engineering or object-oriented development or CMM or ISO 9001 or RUP, then sort of Agile methods and Scrum and Lean and DevOps and continuous delivery. If there's a great new methodology, boy, I try to jump on it as quickly as I can. And that's sort of kind of my bailiwick. So let's just talk a little bit. I don't want to spend too much time, but let's talk about the motivation for things like Agile or Agile project management or Scrum or SAFe or DevOps or continuous delivery. What's sort of kind of happening in the marketplace that's driving the demand or the need, or at least the motivation, the fervor, the desire to do these sort of newfangled methodologies? And that's what they really are. They're newfangled methodologies, right? Okay. And it's really a lot of different things, interrelated things like increasing globalization and global competition, outsourcing of IT. We look at corporations like Microsoft 60, 70, 80% of their legacy systems are outsourced to other countries like India, Russia, Ireland, Latin America, even Africa to a certain extent, right? So we're not insourcing big information systems anymore, right? We're outsourcing. Even the aerospace contractors, it used to be a thing that, there was dual-use technologies. We couldn't export commercial avionics technologies, right? Because they could be used as weapon systems, right? We could sell a commercial airplane to China, and they could turn around and turn that 747 into a bomber, right? Or a transport aircraft, right? But now we see commercial aircraft companies are outsourcing their programs. Look at Airbus, right? 10, 20, 30 different countries from around the globe actually help assemble Airbus, right? Okay, so just increasing global competition, right? And if we can't do it better, faster, and cheaper here, our customers will find someplace else to source, whether it's an airplane, whether it's a missile, whether it's a UAV, whether it's a global network, whether it's an information system. If we can't provide the best bid to do the systems in software engineering, cost effectively here, our customers will turn someplace else. And if they haven't started doing that, they will do that more and more in the 21st century, right? So it kind of leads into the next factor, which is the demanding customers, right? There used to be a thing called switching costs. Once we got our customers to buy our products, we had them locked. They were the golden handcuffs. The cost of switching to our competitors would be greater than the benefits they would get from our competitors' products. That's no longer the case. Switching costs are almost zero these days. It's actually another word for it. They call them marginal costs, right? The 21st century is bringing on the concept of zero marginal costs, right? Okay, so we no longer have our customers locked in. Domestic suppliers of airplanes, the demand for Airbus almost, is 2-to-1 against domestic aircraft, right? It used to be that domestic aircraft, we had our customers locked in. That's no longer the case, right? Okay. So obviously, these two factors are leading to downsizing, better, faster, cheaper. It wasn't 10 or 20 years ago that the average IT budget of a Fortune 500 company was like $200, $300, $400, $500 million, $500 million, right? So if you were an insurance company, like Blue Cross Blue Shield, you were spending a whopping $500 million a year, mostly on ERP systems, right? Human resource systems, right? Well, today, most IT budgets are down in the 50 to 75 to 100 million, about 20% of what they were 10 or 20 years ago. Look at the US courts, IT department, $115 million, right? Okay, their entire IT, $115 million. And so not only have we reduced our IT operating budgets by 80% in just 20 years alone, our expectations, our requirements, our demand has either remained the same or increased. So we're asking our suppliers actually to do more with less, right? We think because you've reduced your annual operating budget by 80%, you're going to expect less from me. No, you're going to expect the same backlog from me, if not more, right? And that leads into some of these other factors, right? Obviously, system complexity, right? Systems are infinitely more complex than they were in the 1940s and 50s when concepts like project management and systems engineering were born. Really, that was the impetus for systems engineering in the 1950s, as the electronic computer was born out of World War II, and systems were just so complex, and we needed to plan and manage and execute these programs so carefully. Well, today, information systems, even avionics systems, are infinitely more complex than anything any physicist or engineer could have ever dreamed or imagined in the 1950s, right? Look at something like Microsoft Office, has something like 100 million lines of code, right? And you break any one of those lines of code, right? And all the world's hackers just kind of jump into your personal computer, right? So today, systems are infinitely more fighter jets. 80 to 90% of the functions executed by our fighter jet are actually in the software, in the mission computer. It's not the airframe, it's not the engines, it's not the turbofans, it's not the radars, it's not the ejection seats, it's not the heads-up display. 80% of fighter jet functions are in the mission computer, in a memory about that big. So if 80% of your cost is in a chip that big, that's where your complexity is, right? So systems are infinitely more complex today than they were, right? And this presents new challenges. And technological change is just dogging us, Gordon Moore said in the 1970s that a microprocessor would halve in speed or double in speed and halve in cost about every 18 months, right? Well, that continues to dog us in the information technology world, right? If we begin planning a 5 or a 10 or a 15-year program, within 18 months, whatever technology we've decided to commit to that particular program is going to be obsolete, right? And then if you believe Ray Kurzweil and the singularity principle, actually, the time between innovations is actually shrinking, right? Okay, so if you're a program manager or systems engineer and you're going to plan or execute a complex systems and software engineering program, the worst enemy you have is yourself in time. So you've got to be able to deliver something of value within the time frame that the technology is no longer obsolete, or design an architecture that can evolve with technological change. And we still have the same old problem of vague requirements, that our customer will not know what they want until they see it, right? We knew that in the 1970s. Today, we've actually learned, scientists have told us that 80% of customer requirements exist as tacit knowledge, not as explicit knowledge. They exist in the mind of the beholder, and they will not tell you what their requirements are until they see it. No matter how much you spend on the requirements, no matter how much you spend on the WBS, no matter how much you spend on the architecture, your customer simply will not know what they want until they see it. And that particular problem continues to dog us today, right? And all these factors just kind of churn. That's why it's in a wheel, the churn, right? And it causes really, really bad things to happen. Work-life imbalance. Organizations that are extremely imbalanced with too many requirements and too much stress and too much pressure, they're working 60, 80, 90 hours a week, right? That's Microsoft in 1985, right? Sleeping under their desk, right? Okay? The attrition rates are extremely high. The cost overruns are high. People are quitting. The scope is escalating. They actually call these runaway projects. And if somebody actually has a little bit of courage, they would actually cancel one of these programs because they're just simply out of control, right? Like Sentinel, right? They spent, $500 million, the FBI, on Sentinel before they decided to what? Stop the program. Same thing happened to the space station. We spent $14 billion before somebody said, stop, okay? And don't come back to me for more money until I see a physical system in space, right? And NASA finally got the message that Congress did not want a system specification. They wanted a pressurized module launching the next space shuttle mission into space. By 1995, NASA finally got the message that we needed to see real, living, breathing hardware in space, right? Okay? All right? And there's just a host of other problems I won't spend a lot of time on here, but, obviously 80% of the problem is that, 80% of our budgets are tied up in legacy systems, right? So if I've got a brand new mission requirement, right? I've got a terrorist doing new things to me, global hackers hacking into my DoD networks and satellites, and I've got this great idea for a $4.3 billion, cybersecurity information system to protect global networks. That's great, but you have to realize that 80% of your budget is tied up in the legacy assets, right? Okay, that creates a problem, right? Poor IT security has never been a greater problem than it is today, right? We used to engineer systems in the 70s, 80s, 90s for 400 users, right? We used to say, oh, we'll have 400 users are going to use this case file system. Great. Really, you only had 40 people regularly using any system, maybe 4 that just used, we call them power users, right? Why do we engineer systems for 400 users when we really only had 4 power users for the average DoD system, right? Okay. Well, today the dynamics have infinitely changed, right? Okay. We've got 7 billion people on the planet, right? 3 billion of them are on the internet every day, producing trillions of packets, right? Look at somebody like Facebook, has 500 million users, right? I believe the latest count of cell phones in the world is actually 7 billion. Actually, the latest volume of active cell phone subscribers in the world is 7 billion. Okay? And these systems, they have to perform right. They have to function correctly, right? They've got to send bills to their subscribers. They've got to get pictures and text and videos. And hackers shouldn't be able to break in and steal your text messages, right? The requirements on today's systems are extremely, extremely rigid for IT security, right? Interoperability becomes a problem. There is no more power, space, and cooling in the federal government. If you add a data center, you've got to take something away, right? We have this problem at Fort Meade. You just can't add a data center, right? You've got to take something away. Same thing in the federal government, right? And this is actually a study by the federal government that said the average length of a DoD IT project was 81 months. Personally, I can't believe this because I've never worked on a DoD IT project that was under 120 months. But some guys said the average length was 81. Well, that's already created a problem, right? Because by the time you get 15 months into that project, your technology is going to be obsolete. The requirements have changed, right? Your people have probably quit, burnt out, or had a heart attack, right? So if we're systems engineers, we're going to hang our hat, or project managers, or we're going to hang a hat on, the iron triangle, scope, cost, and schedule, right? How are we going to hit that target? Okay, so these are some of the motivation for why lean and agile methods are starting to emerge to address some of the problems on that particular chart. Okay, all right. So let's see what the sort of the principles are, the values of this notion of agile methods, right? Well, agility is a property consisting of quickness. Oh, we got to be fast, right? I can't wait 81 months. I can't wait 120 months, right? It's got to be light. I've got to be disciplined, all right? I can't put off all discipline, but if I'm going to move quickly, I can't build a specification that's 8 feet tall, right? It's got to be disciplined, but it's got to be light, right? It's got to allow me some flexibility. As I start delivering real hardware and software to customers, right? The notion of what you see is what you get is going to kick in, and they're going to say, oh, is that what I asked for? That's not really what I wanted. And I've seen this over and over and over again. I worked on a radar, command and control system for the Air Force. It was $150 million. It was just a small one, right? We spent about 5 years just updating it, right? All we were doing is updating it, right? Okay? And when the general saw it for the first time, he said, oh, is that what I asked for? That's not really what I wanted to. And he literally changed the requirements on the spot. It's what you see is what you get, right? So if your customer is finally going to realize what they want in spite of what they asked and paid for when you're done, you've got to be able to move, to shift, to adapt to those requirements, right? Okay? So it's the ability to respond to change. What change? Your customer finally waking up and realizing what they really want. What kind of change? Technological change. What kind of change? Mission change. What kind of change? Priority change. This is a problem in the organizational change field, right? By the time you get your executives to commit to a budget and timeline and an organization to do change, you say, if you give me $50 million, I'll shift from no engineering to systems engineering, right? By the time the next year's budget cycle comes around, they're not even going to be interested in that organizational change initiative. That's how fast, change happens. So what you've got to be able to do is deliver something of value before what? Before something changes, right? And that's what we're going to try to do, right? So once the change has been realized, a hacker has figured out a new way to break into your global network, your super secret global network. That's the change. It wasn't on the plan. It wasn't on the schedule. It wasn't on the roadmap. It wasn't on the WBS, right? Some hacker just woke up and broke into your super secret network, right? That's the change, okay? You've got to be able to quickly reprioritize and say, okay, that wasn't a requirement, but what can we do to respond to that requirement? That's the new requirement, okay? It wasn't in the scope of the project, that's the new requirement. So once you reprioritize and replan your program, you've got to give a fast response. What, 81 months? No, he just broke into your network and downloaded, 10 million, I don't know, top secret security, applications, right? You've got to be able to give a fast response. You've got to lock it down. Okay? But you can't shut it down. You got to lock it down. All right? It wasn't on the WBS, right? And the only way you can do that is by interacting with your customers, right? You've got to talk to people. You don't send them emails. You don't send them RFPs. You don't send them requirements, okay? You don't send them DODAF diagrams. You say, Mr. Head of OMB, some hacker just broke in and downloaded 10 million, security applications with all that PII. What I can do is I can upgrade to this secure operating system, shut down these routers and bridges, and create a new user interface, and people can continue business as usual without the hackers. But I need your permission. We don't have time to put out an RFP. Can I do it now? You've got to talk to people. That's the difference between the old and the new way. You've got to be able to talk to people, right? All right? And then you've got to do this in an evolutionary, incremental, and iterative way. What does that mean? I like to use the phrase, you eat the elephant one bite at a time. Complexity is an elephant, right? We're not, the world's requirements are an elephant. Fort Meade's requirements are an elephant. NASA's requirements, the Air Force, the Navy's, the DOD's, the commercial marketplace, the world, it's an elephant, and we can't solve all the problems at one time, but I can eat that elephant one bite at a time, right? Okay? All right. And why do we do all these things? Change and reprioritize and fast response and talk to people and eat the... We do that to create business or mission value, right? Okay? Because what's the mission value? Lock down the networks but continue business as usual. What's the business value? I need to capture more market share. What's the business value? I need to come up with a new model that's better, faster, and cheaper. What's the business value? I've got to attack some of Airbus's market share. What's the business value? I've got to come up with a data center with some newfangled cloud computing technologies like Mongo. Okay, what's the business value? Okay, I've got to keep my people from quitting, right? Right. Biggest problem in the DHS is morale. People hate the DHS. And I know from firsthand experience, DHS is not the worst government agency to work with. Okay?
You left out of the question.
It's not Fort Meade. It's not Fort Meade, all right? So let's continue on, right? So we've already alluded to this, right? Okay? So we're going to start speeding up here. So the notion of agile methods sort of kind of emerged about 1995. Okay? And it was really based on 4 broad values. People need to collaborate. You need to see the whites of their eyes. You need to talk to people. You need to see, are they smiling? Are they happy? Are they angry? You need to read body language, right? You need to talk to people, right? And I see this problem all the time at Fort Meade. We get a new engineer on the project, doesn't understand the system, and the first thing he does is send an email to somebody 5 feet away from them, right? And I could hear the keyboard typing. I say, Steve, what are you doing? Well, I'm sending Colleen an email that I don't like her. I said, get up from your desk, stop, get up from your desk, walk over there, and you and Colleen work it out. That's a true story. right? We need to be able, if we're going to solve problems faster, we need to collaborate. Actually, 2 people can solve problems faster than 1 person working alone, right? Okay, I see this all the time on engineering projects. It takes a really good engineer, scientist, or physicist about 15 months to work out a real hard problem. 2 people working together, it's about 2 hours. Same thing happened to me on my Air Force project. I joined my radar command and control. They've been going for 5 years. When I got there, didn't have a single line of code. They asked me, Dave, first day on the job, what do you think we should do? And I said, well, I think it's time for us to start programming. They said, well, okay, what do you think we should do? I said, well, I've been here for 1 day. What's your hardest problem? Well, we need to marry the radar, right, to the image processing algorithms. I said, great, let's do that. I said, who's your best engineer? Tom. Tom, come here. 2 hours later, we married a 1950s radar to a 1995 image processor. 2 stinking hours. What 25 engineers didn't do in 5 years. And that's not the first time that's ever happened to me. 2 people can solve a problem, faster than 1 person working alone. But it's not through email. They've got to talk to one another. All right? It's about teamwork. That kind of leads to the next one. It's about people working together, right? And it's about focusing on something of value. Yes, I'm a believer in project plans and systems engineering plans and requirements and architectures. Love the hell out of them. I'll do that night and day, all day long. I'm not against that, right? Okay? But the real business value is in delivering real hardware and software, real physical things with blinking lights and GUIs. I was just telling Ellie earlier today, one of my first tasks on space station, right, was creating the graphical user interface for the astronauts to actually fly the space station, right? The engineers had actually been working on this for several years, and I was looking forward to writing some good documentation, and they said, Dave, we need you to code the graphical user interface. I said, what? Right? We were the first team out of literally thousands of people that coded the first graphical user interface, and we literally electrified the space station. We were the first team that ever produced any working code for space station. Okay? All right, so there's got to be the shift in value that you got to focus on the stuff that the stuff that really answers the requirement, the stuff that really answers a mission need, the stuff you can put in front of your customers so they'll say, oh, that was a really nice graphical user interface, Dave, but I would really like it to be like this instead. Right? That's the tacit knowledge coming out of their head. That was a cool graphical, but it looks too much like the space shuttle graphical user interface. Can you make it look a little bit more like my Macintosh? Right? Okay? And these are sort of, and really probably the biggest value, in the Agile system, in the Agile worldview, in the Agile paradigm, is probably this bottom one, right? If all else fails, if you talk to your customer and they hate you, right? If your team screwed up and Steve and Colleen can't work together, right? And you didn't produce the working system and software, you've got to be able to change, right? In spite of what that WBS says, in spite of what the RFPs it says, in spite of what the project plan says or the architecture or the requirement, you've got to be able to respond to change. Why? Why? So you can give the customer what they really want. So that has to be built into the contract. That we're going to have a broad scope, we're going to have a vision for this contract, and we're going to talk a little bit more about this in a minute, right? And here are the big value-adding, low-hanging fruit that we want to build within this vision. But when something changes, when I finally realize, wake up and hit my head on the coffee table and realize what I really want, there's got to be enough flexibility within that program to change and adapt to what I really want. And I heard one of the creators of the Agile methods, I believe it was Andy Hunt, he said, of all the Agile tools, of all the Agile methods, of all the Agile philosophy, values, and principles and technologies, the one that's most important is the ability to adapt to change on a daily basis. You come in as a team, and you say, what's my problem today and how do I solve it? And if I'm not doing anything to solve that program, I got to stop doing what I'm doing that has no value and start doing something today that has value. It's the ability to respond to change, right? Let's continue on. So Scrum was out of many Agile methods that emerged, like extreme programming and feature-driven development and dynamic systems development and crystal methods, and just the list just goes on and on and on and on. There was even I think there was an Agile version of RUP. I can't remember anymore. My brain. I think Scrum sort of emerged as the methodology, as the framework that sort of satisfied that value system, that paradigm, those expectations of collaboration, of teamwork, of working software and changing, right? And we had this notion of a product backlog. This is your stack of customer requirements. Well, that's a surprise to some people today, because people believe that Agile methods are the thing you use when you have no requirements. Really? Well, that's the first box on the left of the chart. First assumption is you got a stack of requirements, right? And they're in priority order, and it's not very deep, right? Okay? We'll talk a little bit more about that in a minute, right? Because, yeah, here are all the nice to haves that your customer wants. But you got to collaborate with your customer and say, okay, thanks for giving me that stack of stuff. Which one do you want first? Well, your customer's going to say, I want all of it. Take 81 months and call me when you're done. Right? When you say, no, see, there's this notion of change and value. Which one do you want first? Well, if I could have this global network that sends data back and forth in a secure manner, I think that would be really cool. Great. We'll build that right away. Okay? All right. So once we do that, we're going to decompose that brick, that capability, into a set of technical tasks that we can execute in 2 to 4 weeks. And we call that the sprint backlog. So this is a list of customer requirements in customer language. This is a list of technical tasks in engineering speak. Got to buy the server, got to install it, got to get some training, got to get some certification, got to code some middleware, got to procure some hardware, got to get a server farm. It's a list of technical tasks that you've got to do to fulfill that customer requirement, right? Okay. Once you understand what your backlog is, and once you've decomposed at least the first brick into a set of tasks, then you've got to execute it, right? Literally on a daily basis, you will actually start executing those technical tasks as a team. Every 24 hours, you'll meet as a team and you'll ask yourself, what have I done today? What are the impediments that I have? And so forth and so on, right? And then every 2 to 4 weeks, right, you're going to show your customer some real working hardware and software with blinking lights. It's almost like the old gladiator days, right? You ask your customer to give you a thumbs up and a thumbs down. Well, what do you think of my first version of the global network that sends megabytes of data back and forth at light speed, in a secure fashion? Is that what you wanted? And your customer says, no, maybe, do some more work, or yeah, thumbs up, move on to the next brick. Okay? So, and there's another step in here that's not shown. It's the process improvement cycle, right? Once you've actually built one of those bricks, that's the Andy Hunt question, okay? How can I do this better, right? That's the learning curve problem, right? We've known this for decades. Physicists, engineers, scientists have known this. The learning curve actually comes down from increment to increment to increment, right? You actually see order of magnitude. After about 7 iterations or 7 sprints, the cost of the seventh sprint is about 10% the cost of the first sprint. Because during the first sprint, while you're building the first version of that brick, you don't know what the heck you're doing, all right? By about 3, 4, 5 months later, now you've got it down to a science, right? That's the learning curve, right? The first F-117 cost what? $100 or $200 million. The 6th or the 7th or the 8th F-117 cost about $10 million. That was the learning curve. And Lockheed Martin knew this. Well, they weren't Lockheed Martin at the time, but Lockheed Skunk Works knew this, right? They said, well, the customer's only given us $3 million. And the first F-117 is costing $150 million. That's half our budget. But we know the next one is going to be $120 million. The next one's going to be $100 million. The next one's going to be an $80 million. By the seventh F-117, they're going to love the hell out of us, right? Okay? And they're going to give us more money. And by that time, we're really going to know what we're doing here. Okay? And that was sort of the Scrum concept. And it was great. It works out, literally 80 to 90% of worldwide projects are really small, can be done by about 5 to 15 people. When Scrum was born in the early 90s, these guys were practically geniuses. They didn't study some academic research paper and say, oh, here's Scrum. Well, actually they did, but that's a different story. Okay, but the notion was these were guys, that really bent metal and cut code for a living, right, when they came up with Scrum. And then, this solves 80 to 90% of problems really, really well, okay? But then there's a really big problems, right? Now build an ERP system. Now build a global network. Now build a data warehouse. Now build a case file system. Now build a fighter jet. Now build a mission computer. Build a space station. How about a deep space probe, right? When things get a little bit big, the scope kind of expands and this backlog gets really big and nasty, right? Okay? So the notion of Agile project management was born to kind of help address this. Now, I won't spend too much time on this slide. It's sort of similar. It's a notion, it's still a project management process that gives us some flexibility in scope, right? Deals with some level of uncertainty because our customer's not going to know what they want, right? It's really going to be well suited for high-tech environments, right? Because high-tech environments are associated with complexity, right? It's going to really focus on human interactions and communication more than engineering and documentation, right? It's really going to focus on business and mission value. And we're going to be able to quickly but reliably create products and services that have value to our customer. Really, it's a project management process that's lightweight but disciplined, particularly well suited for what? Engineering problems, because engineering problems tend to have a greater than average level of uncertainty and complexity and mystery. That's why our customers pay us big bucks. I don't know if you've seen the latest salary surveys, but systems engineers almost make more than lawyers and doctors in the United States now. I don't know if you knew that. And the reason they're paying you more than lawyers and doctors, because our problems are harder. Right? There's a lot of uncertainty. Nobody knows how to build a Hadoop data center that can ingest 10 petabytes of data, sort through it, find the needle of the haystack in 3 seconds, and then give it to an analyst, right? So they can do something smart with it, like buy a new company or drop a 500-pound bomb on a terrorist, right? Right? That was a really complex problem, and we spent about $2 billion here for me building our first one. It was really, really hard. Okay? But once you got it, it was like, is that all? Once we were done, it's child's play, right? But they paid us a lot of money to solve some really, really hard problems, right? The systems engineer who led that particular project actually won Systems Engineer of the Year, by the way, and then retired. Good for him. And he was young, too. All right, let's continue on. So by the mid-2000s, or 2010s, I should say, about 2002, people started moving beyond Scrum, right? So, well, we need a project management paradigm. We've seen Scrum. Scrum is cool. People are still, I don't know if you knew this, if you have seen the latest, 95% of worldwide IT projects that apply any methodology today are using Scrum. Okay? That's an amazing statistic, right? Okay, but people started saying, well, we need project management layer on top of Scrum. We're going to see that on the next slide. Okay, other notions: radical project management, extreme project management, adaptive, agile project management, simplified agile project. Well, there's like 15, but I just wanted to put a few on the slide. There's like 15, 20, and look on Amazon. Every time I look on Amazon, there's a new book on agile project management, right? Okay, they're just popping out like wildflowers, right? Okay, but they all seem to have some sort of similarities, right? They have visions and scope, right? We need a scope of this project, right? Okay. We need a plan. Once we sort of understand the vision and scope, we need a plan or a roadmap, right? Okay. We need to be able to execute. Once we understand what the high priority requirements, we've got to execute very, very quickly, right? And we've got to be able to deploy these things. And we'll talk a little bit more about that. Deployment is really, really big buzzword these days in DevOps and continuous delivery, right? And we've got to be able to do process improvement, right? That's the most important part, right? I mean, we knew that from like 1925 when Duran and Deming were running around the Hawthorne works trying to figure out what was wrong with their operations. They got to do continuous improvement. Thank you, Dr. Deming. That's exactly what we need to do. Can't forget that. Okay. All right. So this notion was, you know, Mark Layton looked at all. This is actually one of the best-selling books, and we're going to give away a copy here today. Mark Layton looked at all the approaches and said, well, what's a nice little layer that we can put on top of Scrum to do a little bit of planning for slightly bigger things in a 5-person project, right? These are really the basic mechanics of things like the scaled agile framework as well. You've got to have a vision. You know, even architects do this. The mayor of New York says, I need a new bridge to cross the Hudson. The first thing they do is get an artist and he paints a picture, and a couple of weeks later they show him a couple of pictures that we'll build that bridge for $200 million. We'll build this one for $500 million. We'll build that one for $2 billion. Which one do you want? They actually do an artist's rendering first. That's the vision. You've got to have an artist. I need a data center that holds 30 petabytes of data that I can sort through in 3 seconds and find the bad guys so I can drop a 500-pound bomb on it. That's a vision. So we used to call that an elevator statement. I've got to be able to communicate in exactly one sentence, right? In 30 seconds or less, what in the heck am I building, right? Don't need a specification, don't need an RFP, don't need an SOW, I don't even need a DOEA level 4 certified guy here. Just in one sentence, can you tell me what we're building? Right? It's called an elevator speech, right? And that's the first thing you've got to do, right? And then that elevator speech, somebody says, okay, well, and this vision could be big. I need a global network of interconnected data centers to I don't know, database, you know, 65 different kinds of data and sort through it in less than an hour and find the bad guy who's twittering bad things about the President of the United States. That actually is a true story, right? There was a guy from Ireland, and he twittered that he was going to fly to Hollywood and bomb, you know, what do you call it? I'm trying to think of some movie star, and you know, it was some sort of Irish expression that meant he was going to photobomb it, right? Well, the DHS caught that Twitter in about 3 seconds and arrested that guy and pulled his passport. He can't come into the U.S. ever again, right? So you got to be able to sort through 30 petabytes of data, find some bad guy twittering something bad about somebody important, then you got to arrest him and put him in jail for the rest of his life. And that could be the vision. It's a big, big global complex system, right? So you need a roadmap. It's not a project plan. It's not a WBS. It's not a Gantt chart. It's all the building blocks. Well, I'm going to need a network. I'm going to need a data center. I'm going to need some power. I'm going to need some people. I'm going to need some operating systems, maybe some Hadoop technologies. I'm going to need some programmers. It's a big building block. It's not a schedule. What are the big building blocks that you're going to need to implement that vision? That's what we even have one at Fort Meade. We've got a roadmap that says where we're going to be 5 or 10 or 15 years from now. It's not an executable project plan. It's just, well, in order to be the Fort Meade of the future, I'm going to need one of these, a parking garage. I'm going to need one of these, a building over here. I'm going to need a taller fence over here. You know, I'm going to need trained people over here. I'm going to need to merge with these agencies over here. I'm going to need to secure the network over here. It's the big building block, and that's what we need. To build big and complex things, we need roadmaps. And then once somebody says, okay, thanks for that vision, the global network to end all global networks, right? And the, you know, you're going to need, you know, I'm going to need a data center. Okay, great. We need a data center. It's got to be someplace with cheap, reliable power. Okay, we'll put that in San Antonio. Got a most reliable power grid on the planet. Okay, well, now you've got to plan it out. So block number 1 is we're going to build a data center in San Antonio. All right, you're gonna need a plan. Now go ahead and bring in your Primavera master schedule and put together a WBS and schedule that thing out and do earned value management on it and tell me when we're done, right? That's the plan part, right? We're gonna need a plan, right? And then once the first WBS task is what? I don't know, lease a building, okay? Now you give that to the engineering team. That's their first task. They look at the technical requirements and say, okay, in 2 to 4 weeks, I'm going to have a building necessary to hold 30 petabytes of data. What do I do? Well, I'm going to need to evaluate who's available in San Antonio, what's the best price, who meets our HVAC requirements, and who will sign me to a lease within 30 days. And that's your technical engineering plan, right? So that's the sprint plan, what your engineers are going to do to execute the first WBS task, right? And then every day they're going to say, well, how are we doing? Well, my task was to identify potential suppliers, okay? The problem was nobody meets our HVAC requirements, and I don't know what to do. We faced that problem. We bought a $10 million data center to host 10 petabytes of data. We shipped it to the data center, and it didn't plug in. Somebody screwed up big. Systems engineers are really, really good at this. I'm not picking on us. I'm a certified systems engineer too, somewhere. We make really, really big mistakes. When we make mistakes, we make mistakes. Yeah. That's sort of the essence of systems engineering, right? So we have to throw it away and buy another one. Call the vendor, sorry, the last one we bought from you didn't plug in. Can you send us another one that meets these HVAC requirements? Oh, okay. You just lost 30 days right there. Okay? All right, so you got to talk to one another. You got to communicate in these daily scrums, right? Okay? You got to show it to your customer. Okay, my first task on the WBS was to get a data center, cheap, reliable power grid in Texas that hosts 30 petabytes of data. Here's the one we got, and we just put it on this. What do you think? Got to get your no, maybe, or yes, next WBS task, right? And then you've got to do what Andy Hunt said to do in 1995. Okay, what do we do better? Well, what do we do wrong? Well, we bought a $10 million, server farm that didn't plug into the HVAC system. Why? Well, because I guess we didn't talk to the company correctly and send them the specifications for our server farm. Okay, so what's the lesson learned there? Well, we need to engage the supplier earlier to ask them if their facility will host our server. Okay, all right. That's going to save us a lot of money next time. We actually did that same project, right? We're actually able to triple the capacity of our server farm, right? Just by updating the firmware and our existing hardware, right? That's the process improvement. That's the learning curve, right? So we're actually triple the capacity for 1/10 the cost by the time we delivered that system. That's why that guy won Systems Engineer of the Year and then retired by age 45, right? All right, because you saved the world for 1/10 the cost, right? Okay. That was the retrospective. What do I do to make big mistakes anymore? So let's just take a quick break here. I'll give you 2 minutes. Any questions or comments? Because I've run through one heck of a lot of it. We're going to look through the individual steps of some of these things we've been talking about. Any questions or comments? Anything we've talked about here today? We've got a question over here. Yes, sir.
Hi. So on the Agile part, and it's whether it's either your development or a PM, the assumption is customer interaction. Whether it's intensive or your engagement. And one of the big challenges always is, hey, I don't have that. They don't want to engage. So how do we deal with it? And I want to see, it ends up being inevitably, you basically show me the rock thing, right? If you don't get that, you build stuff, you show, is this it? Is this it? And how about this? How about that? You may or may not get feedback, and you keep doing it until you run out of money, right? Either they say, yes, that's it, or you run out of money kind of stuff. What in the real world, the stuff you've been associated with or have heard about, how they overcome those challenges besides just run out of money or, doing things? Because lots of times, whether they want to or not, they may not have the resources dedicate this dedicated customer to do it, or whatever various reasons. So any thoughts on that? Because that's the challenges I've seen in a lot of this stuff, that way it's not optimized in what we're trying to do.
So you've asked the question of the hour. The collaboration part is probably the hardest problem, especially with a key decision maker, the guy holding the money. We ran into this on this data center here at Fort Meade, right? The guy holding all the money, okay, said, go forth, and we were literally using Scrum, and every 30 days we were building we weren't just saving the mission, we were actually executing the mission every 30 days. We were collecting real data from the field, hunting for real bad guys, and trying to show some senior decision maker with $100 million in pocket what a great job we had done. And you know what? The senior decision makers kept on saying, Jan, tell us when you're done, call me in 81 months. So yes, it's really, really hard to get the guy holding the money into the room, right? So Scrum sort of has a way to do that. It's not fail-safe or foolproof. Part of that is they have a product owner, right? So they have a full-time person who actually acts as the customer, it's a proxy for the customer, who's at least interacted for the customer, has the authority, has delegated the authority to make scope decisions and to interact with the team more frequently. Some people throw rocks at the product owner, but I've actually found it to be a very, very effective. If you can keep the team small, if you can keep your customer interested, that's really the part. Sometimes we can do that through training. Sometimes we can do that by keeping the scope small, and sometimes we can do that through delegated authority. But it's a problem that's been dogging the Agile world for decades. We'll have at least one more question, and then we'll go on. Yes, Kurt, go ahead.
In the Scrum slide that you had with the loops and everything, the flow was basically forward. And the bugaboo that I have is mostly around technical debt that then builds and builds until you reach a point where either you refactor the whole system or a catastrophe occurs because of decisions that are made early on that were done expeditiously in order to meet the Scrum timeline.
Okay, so I'm going to paraphrase, it's technical debt. It was a problem that arose very, very early in the Agile community. It was the old question of cost versus quality, or speed versus quality. Is my highest priority going to be speed, or is my highest priority going to be quality, going to be scope, right? All right, okay. And so Agile teams were sort of kind of rushing through, and they were saying, okay, I've committed to 15 system requirements in the next 2 weeks, all right? And so I'm going to sort of kind of do them half-baked, right? Or maybe I'll spend 80% of my time on the first 2 system requirements, and then when I'm up against the edge of the sprint, I'll rush through the last 13 requirements and I'll do them very badly. Or worse, I'll save testing. I'll just code and code and code and code, and I won't test. We actually have run into this program. It's not just here, but even at Fort Meade, where we've literally gone from sprint to sprint to sprint to sprint, right? Okay, we built up 5, 10, 15 million lines of Java code, and then at 9 months, we try to test everything, and what happens? The whole acquisition comes crashing down, and we've angered everybody and their brother, right? And nobody wants to give us a contract again, right? So really, this really wasn't a part of the first Agile team. The Agile team was, a requirement wasn't done until it was tested and validated. That meant that you have to have validation. First, you have to have a requirement. You have to have validation requirement. You have to have a test, and the notion was this is actually part of extreme programming. 2 people grab a high priority requirement, okay? They code it, they test it, and if it's passed the validation test, they drop it into the baseline and they move on. And you don't pull the next requirement off the backlog until the requirement you've worked on. So let's say that I plan 15 requirements for the next 2 weeks, all right? And the first requirement turned out to be a real bugaboo. Okay, and it cost me all 14 days. And I left 14 requirements undone. That's a good thing. Now you ought to tell somebody, You got to tell the customer, oh, by the way, we've run into a really big bugaboo. The map reduce routines don't really work, on this particular server farm really, really well. And I know we promised to do complete mission profiles in the next 14 days, but all I have is one little user query. So you got to tell somebody that's the communication, that's the transparency part. And they should have some authority to say whether that's okay. Do you need more people? Do you need more resources? Maybe maybe I would rather have 4 other low priority requirements instead of that really bad bugaboo. So you ought to talk to people. But the notion is that scope should slip in the Agile paradigm. And what the early Agile teams, mostly out of lack of training, all right, and lack of experience, they were rushing through and they were pouring out poor quality code, right? And really we're starting to address this more and more with modern paradigms like DevOps and continuous delivery, right? Where somebody says, I need a new requirement. I need that Google search engine. I think we can optimize these algorithms. If you use this mathematical thing, we can speed up the query by 0.2 of a second. Okay? And 2 programmers sit there and they look at the search engine, they make the change, and they drop it into the baseline and they test it against the entire plane. Google literally runs 75 million tests a day for each requirement they drop into the baseline. And the notion is the requirement isn't done until it is validated, right? Amazon Web Services does exactly the same thing, right? So we're sorry, it really is we're starting to solve this problem more with, technology, tested, continuous delivery and DevOps. Even DHS, does this, right?
Right. And
So we haven't solved that problem completely, but it's what we're trying to
right,
do.
Dave, and I think what you're talking about is also Kaman, how you're finishing a problem. It's not finished until it's finished. You don't go on to the next one until you finish one, like you were talking about the requirements. So you don't do 15 requirements, you do one.
So
you finish it no matter how hard it is.
So yeah, I didn't want to bring up the lean thing, but thanks, Gundars, because this is an Agile talk. This isn't a lean talk. But yes, he's right. This is sort of the hallmark of the lean community, right? Is that, you have a small number of requirements on the queue, right? On the queue over here. You don't have a lot, 4 or 5, right? And you allow one requirement to the queue, and you don't allow another requirement in the queue until that one is done and validated, no matter how long it takes. So the notion is Kanban does that in a manual, sort of slower way. And game developers really love the Kanban concept, right? They say, hey, Dave, what I need you to do is to wireframe a new action figure that, I don't know, pulls out a lightsaber and does one of these, right? And I'm the artist, right? And I want to spend 4 weeks doing that little motion right there with the arm like that with my little wireframe. So that's my requirement. Lock my door, leave me the heck alone, and I'll tell you when I'm done. So game developers really like this notion of, I'm not going to take another requirement on my plate until the one you gave me is done. What we're doing in the Agile community, the DevOps, is we're doing that quicker, right? We're doing that. We try to do that a little bit faster than the Kanban folks. So good question. Let's go ahead and move on so we can wrap up. When is the drop dead time here? We don't have that many more slides. 10 minutes? Okay, 10 minutes is the deadline. Okay, so let's go ahead and continue on. So I'm not going to go through this, but it's a notion. We need an elevator speech. I've already told you about. This is kind of a format for an elevator speech, right? You have to be able to answer the question, who is it for? All right. Who's the ultimate end customer? Who's going to use it, right? What is it that you're building? What is it a type of, right? Okay, what are its primary, features? What differentiates it from the customer service? And can you state what our product is in a single statement, right? And this is actually one of the primary success factors of Agile project. This is what the project manager does. Got to make sure he doesn't write this him or herself, but he's responsible for making sure that one exists. You got to talk to the customer, you got to talk to the team, you got to talk to the end users, and you got to say, and you've got to form one of these. You got to have a vision. I don't know if you knew this. Like Google does what they call a statue, a vision for each new product they're going to build. They actually put a statue of that product, and when that product is done, the statue is actually placed outside of Google headquarters. So all the statues of all the finished products at Google are on display in front of the. So it's a vision, and this is one of your primary responsibilities. A, to make sure one is done, to collaborate with the team to do it, and to constantly communicate it. Why? Because engineers get lost in the weeds, right? We're down in the code trying to optimize the algorithm down here. Leave me alone. I'm trying to get one more second out of this query search engine, right? We got lost in the weeds, and the project manager has got to say, okay, all engineers, stop optimizing your algorithms, come into the room. This is the vision of what we're building. You know, I hope whatever you're going to work on today satisfies this vision. It's one of the primary functions. And this isn't a Scrum concept. This is an Agile concept. This goes back to engineering. This goes back to decades. It's one of the primary functions of the system, the chief systems engineer, is making sure a vision exists and constantly communicating, reminding the engineers and the physicists what the end result of what they need to do, what they need to build for the customer, for the mission. And it's not just about optimizing algorithms, it's about killing bad guys better, faster, and cheaper, right? Okay? And once you do that, you've got to have a roadmap, right? Somebody goes, in order to implement that vision, what are the big building blocks that I need? I'm going to need a data center, an operating system, I don't know, a security layer. What are the big buildings? It's not a schedule, but you do have some notion of ordering, right? Well, I think I'm going to work on this one here first. I'm going to work on this one. I'm going to work on this one, right? You have some notion. It doesn't mean you can't reorder the roadmap, right? And then once you have your roadmap, and you say, well, I'm going to build this capability first. I'm going to build the data center first. Then you need a more detailed schedule. We call that a release plan. And we're going to decompose that big capability, that big roadmap block, that data center. It's going to have a server farm. It's going to have some HVAC. It's going to have, you know, security guard. It's going to have an elevated floor. It's going to have, you know. So you've got to have the little pieces. It's got to have the system requirements. We call those stories, right? And we're going to order those stories into sprints, right? And we're going to be able to do some tracking with that, right? Okay? Yeah. And then once the team says, okay, here are the first, you know, I think, you know, we're bold. I think I can chew off 7 of those system requirements and get them done in 2 weeks. The team is going to get together and they're going to decompose those system requirements into technical tasks. Well, I need to set up the server. I need to install it. Going to need a database schema. Going to need some queries, right? Going to need some forms. Going to need to test that. It's a little technical task that nobody cares about but the engineers, right? And they're going to be able to track against that too. Who's working on those technical tasks? How many hours have been allocated to those tasks? And how far along are we, right? And you should be able to track that, right? Because you're going to have a sort of a backlog of technical tasks. You're going to have a backlog of product requirements, and you're going to have a backlog of technical tasks. And the big thing says, I've got a pile of technical tasks, right? And hypothetically, that backlog over time should generally start what? Getting done, right? And it's not just crap that we need to test over here, right? Each one of those requirements has got to be tested. It's built sort of in the lean Kanban style that Gundars brings up, right? All right. Then we've got to demonstrate something, right? Because our customer ain't going to know what they want until they see it. So every 14 to 30 days, I'm either going to bring in the guy with $100 million in his pocket, try to impress him so I could be the next big dog, right? Or if he doesn't want to come to my meetings because he's off jet setting with the other CTOs of the other government agencies, like most of our seniors are doing, right? Then you got to have a product owner. Maybe that's the chief systems engineer. Maybe that's the Agile project. Maybe it's a product owner. Somebody with a delegated authority to make decisions for that $100 million budget, right? All right, okay? And you've got to demonstrate, well, we said we were going to install a server farm. We're going to database 300 terabytes of data. We're going to try to search through it in 3 seconds and see if we can find a high-value target. And we did it. Bingo, give me a high-value target. Dave Rico, bing, there he is, right there. He's talking on his cell phone right now, and he's texting that he's going to go and bomb Marilyn Monroe in Hollywood. Arrest him. That's what that guy from Ireland said. He was going to bomb Marilyn Monroe. All right, he's just going to photobomb. That's all he was going to do. Okay, but that's what he twittered, right? Okay? All right? We're going to do a retrospective, the most important step. All right? That was great. Okay, this is what we did. We said we were going to do these requirements. We did them. We tested them. We demoed them. What could we have done better? Kurt said, why'd you use Hadoop? Mongo could have done that a lot better, man. You know, it couldn't have held 30 petabytes of data, but 3 petabytes of data, and you didn't need a structured schema, and you didn't need to worry about security fields. You could just throw in unstructured data and pulled it out, and we could have updated the server, you know, and tried out, you know, 10 times more requirements. I said, Mongo, what? Okay, you're in charge of the next sprint. You're the Mongo guru, right? Change leaders, right? If your current leader doesn't have the vision necessary to satisfy the requirements, change leaders, right? A demo something, right? I think I'm going backwards or something. Well, I won't spend a lot of time here, but let's just look at some of the metrics that people are using. Velocity, how fast am I going? So speed matters, right? How fast am I going, right? So how fast am I burning down my backlog? How fast am I burning? That's the technical tasks. That's the system requirements. Whoa, can I do a little bit of earned value management? Well, I planned on having 3 requirements done, but I only have 2 done, right? 0.67, it might be my scheduled performance index. Wow, people are actually doing Agile earned value management, right? Let's just see about some of the results of the Agile projects, right? This is actually a study. They looked at about 7,500 projects, and they found out that Agile projects were about 60% lower in cost, required fewer people, were a little bit faster. But here was the most important part, because technical debt wasn't early. Programs that were being executed pretty good actually had 10 times fewer defects. The problem was most programs weren't being executed that well. All right? So this is actually fairly recent data, 2012. So when they started looking at the Agile versus the traditional projects that were following the PMBOK, they found out that Agile projects were about 3 times more successful than traditional projects, right? To me, that's a dismal number. I'm only 3 times better? Should be like 10 times better. I don't think our retrospectives are working out that well, right? Some of the people that were using it at the time, Google, Primavera, Food and Drug Administration for Class 3 certified medical devices. FBI Sentinel was rescued with it. Stratcom, I've already mentioned today. DOD, VA, CIA, NGA, NRO, and all those other little 3-letter acronyms we can't really even say these days, right? The CIA actually put out a memo to all its large integrators last year that says, we're going to put out billions of dollars in new IT projects, and don't even bid on them if you're not going to use Agile methods, right? NGA was the same way when they put out their Agile web services. Everybody, said they were going to use Agile methods, but they found the needle in the haystack. You have to execute Agile methods perfectly. If they saw any imperfection in your response for your RFP, you were gone, right? It's not just do it, it's do it right and better than everybody else on the planet. That's that customer competitiveness, right? Because I can get somebody who's going to execute it perfectly for 1/10 your cost. Oh yeah, that's the globalization.
Dave,
Yes.
I'm time boxing you.
Okay.
Your scrum is up.
Okay. All right. Well, let's go ahead and conclude here. Let's go ahead and conclude. I do want to say here, that I think in summary, what we want to do is we want to involve our customers. We want to prioritize our work. We want to de-scope these things. Don't try to build the Titanic, right? You want to eat the elephant one bite at a time. You want to work in teams. You want to talk versus email and write documents, right? You want to test early so that you don't build a lot of technical debt, and you want to adapt to change, right? All right. We want to
Do the drawing. We're going to do the drawing for the books first. Do you have the drawing? The tickets?
No more questions?
No, we'll hold that till later. You can ask them questions in one-on-one because we're running way over time, and we have to have another presentation here after this.
another presentation.
Yeah, well, we're going.
What's that? Okay.
Eric, did you have a question? I did. Well, why don't you ask while we're doing the,
Go ahead, Eric.
go ahead, ask your question.
Quite a while, and I was wondering specifically, similar to Kurt's question, but maybe a little bit different. Is there any defined literature or any kind of studies that have found sort of what the right, number or sort of quotient is for sort of how long you need to sort of be alarmed? When should you be alarmed by like split stories and sort of kicking the can down the road as you go through your scrums? So when is a requirement getting too old and complexity has risen past that requirement's effectivity into the total system? So, it's a hard problem. All right, we're kicking it down the road. It's a hard problem. We haven't fixed it. We're kicking it down the road. And everything else in the system has been sort of run and tested. And the system's sort of growing and adapting as you go scrum by scrum by scrum. When does that, is there anything that's been looked at regarding that?
Well, that's a really complex question. I'm not sure if I have an exact answer for that. That's a really complex. So first of all, what we should be working on first is the stuff that adds the most business or mission value, regardless of its complexity, right? If I need a database, 30 petabytes of data, and sort for it in 3 seconds and fight a bad guy, and that's the requirement that I need done first, regardless of its complexity, I need to tackle that first, right? Okay? And if in the process, right, I discover, we just can't, and we ran into that, right, here at Fort Meade, right? We spent $150 million on that exact particular problem. We didn't even understand the scope of the problem before we realized we had the wrong technology and we weren't going to be able to solve it with that technology. And finally, somebody had, before the scope escalates into $700 million like Sentinel, we're just going to terminate, we're going to take these as sunk cost, terminate 100, and fire everybody for not being able to solve the problem, which they did. Okay? And then some guy said, who happened to be in Minneapolis, St. Paul, but have you heard of this new technology set called Hadoop that can do that in a heartbeat, right? All right, so I'm not sure if there's an exact answer, but there has to be, there has to be a great deal of transparency. If your customer says 30 petabytes of data in a 400 terabyte data server and get that out in 3 seconds, right? Find the needle in the haystack. You've got to be able to start building real hardware and software, that empirical test. If it can't be done, it can't be done. And I think systems engineers, I've thrown stones at them for sort of sub-optimizing on those algorithms. But one thing I can say in 30 years, systems engineers, real engineers, are deadly honest. If a customer says, I need 30 petabytes of data in this server farm and I need it out in 3 seconds, the engineer is going to say, that's impossible. It can't be done. So any engineer that's worth his weight in gold has got to be able to say, I'm not sure this can be done, but I can do 7 petabytes of data in 30 seconds, and I'm going to need 10 of those server farms. And I got to do it empirical. I think there's still that problem. Is I've seen the systems engineers, over and over and over again. They plan a schedule that's too long. They just start buying stuff, and they sort of kind of build it. You've got to be able to do a little trial and error. And that's really the whole potion behind the Agile method. It's sort of a sense and response. I really don't know how to solve that requirement, but I'm going to try it using Oracle. Oh, couldn't do it. Oracle didn't work. I'm going to try this using Netezza. Ah, shit, Netezza couldn't do it. I'm going to try this using Hadoop. Getting closer, getting warmer. I'm going to try this using Cassandra. Getting really toasty now. I'm going to do this in Mongo. Now we're cooking with gas. And that sort of change doesn't come naturally to people. Sorry, that was the best answer I could give.
Thanks. We got some more work for you to do.
All right.
We've got the first book, it's the Agile Project Management book, and Dave's going to pull a ticket out.
Okay, is that one there? Okay,
Yeah.
Last 3 numbers, because they're like, they're all here. Last 3 numbers are 403. Who's got 403?
There we
All
go.
And hopefully I won't get 402.
Let's do the photo here.
Okay.
Here, why don't you offer that? picture with Dr. Rico.
Okay, good.
There,
All
there
right.
you go.
I didn't know George.
Very
All right.
nice. Thank you.
And the next three numbers are 392.
This is Agile Project Management for Government.
Yeah. This is a really good book. This is by, I believe it's Wernham. Is it Brian Wernham? Yeah, it is Brian Wernham. He's actually one of the top British consultants.
There you go. Let's get a picture of you guys.
All right. All right.
There you go.
All
Very
right.
nice.
Thank you for everybody.
Hey, I know this guy.
Yeah.
All right. All right. All right, guys. Shoot me an email, grab a business card if you want to hang around if you have any other questions. All right. All right. The mug too?
The mug.
The mug.
There you go. Oh, he can't. He's holding his mug. There you go.
There we go. All right.
Here, I'll hold him. Like for you.
Okay.
And shake hands there, Gundor, so we can.
How about we do this?
There you go. All right.
I have to learn how to take these.
It's actually.
I'm used to taking pictures, not taking them in them.
All right, guys.
All right, let me just say one.
Did you guys have some announcements you need to make?
So we'd like to thank you, Dr. Rico, for coming to speak. And we'd also like to thank Johns Hopkins University Applied Physics Lab for allowing us to have our events here and hosting them every month for our dinner meetings. Thank you all for coming. If you'd like to stay for the installation of officers, we're going to conduct that right now. Thank you. Please turn in your name tags on the way out at the desk exiting the auditorium. Thank you.